Today we are solving a very famous problem called as gambler's ruin. So here we can see there's a gambler that starts with $X and then repeatedly bets $1 on a coin flip, winning $1 with the probability P, losing $1 with the probability Q, which is also 1 minus P. So here comes the question, what's the probability of the gambler going broke before it reaches $A? So before we move forward with the solving part of the video, let's remember some concepts, right? So there's something called as geometric series, which is like, for example, 1 plus 2 plus 4 plus 8 plus 16. So here you can see there's a jump, right, happening, which is with the pattern into 2. You're multiplying with 2, right? So that's one of the examples of geometric series. Then you have to remember this formula, which is a1 1 minus r raised to the power n upon 1 minus r, right? And then there is the summation of two outcomes probability. For example, if there was n outcomes, still the probability will lie between 0 and 1. So that's why the probability is 1 here, because there are two outcomes, either the gambler is winning or losing, right? So here I've drawn a number line indicating the three positions that the gambler can go. So gambler starts from X position, and gambler can go ruin, which is the 0th position, and gambler can go A. But as we can remember that the question is asking us what is the probability that the gambler goes broke. So we are interested in finding when it will go broke before reaching A. So we are interested in finding the probability of going broke before reaching A. So these are the probabilities that we are denoting here. Q of X denoting the position X, QA for position A, and Q0 for position 0. Now we can denote the probabilities value here. So let's say Q0 is our 1, because we are interested in finding that when it will go broke. So the event of going broke will be 1. Q of A will be 0, and Q of X, this is the state we start with. This is the X dollars that the gambler has in the beginning, and then the probability of going X plus 1. Let me draw the number line real quick. So it was our position 0, it was our position A, and this was our position X. So any event happening that leads us near 0 is gonna be Qx minus 1, and any event that is leading us to near A will be Qx plus 1. So we know that the probability of reaching 0 from X position will be Qx plus 1. This is the probability that we will win, and this is the probability that we are going to lose. $1 each, yeah, right, as the question says. $1 by winning and $1 by losing, right? So before we move on, let's discuss the idea of gaps. So here, what can be a gap that we can see? So let's say there is something called as gap gx, right? I will denote the x position with gx, right? Oops. And then gx will be something like qx plus 1 minus qx position, right? So it's something like the difference that we have between these two positions. This is our qx plus 1 and this is our qx. So the difference here is called our gap, right? So this is the event that it's going forward near A. And let's say what will be gx minus 1? It's the event that it's going near 0. So that will be qx minus 1. Now we can call qx as, let's say, from q0 we got many gaps, right, till qx minus 1. So it's like this is our number line, this is our position x, this is our position A, and this is our position 0. So between q0 and qx there are certain gaps that you are adding till qx minus 1, because qx minus 1 denotes one position just before qx, right? So let me write down that equation in a clean way. Qx is q naught plus g naught up to gx minus 1, and we will denote these equations so we can use them later. Let's say this equation is our third. So working on equation third. So our third equation is qx p qx plus 1 plus qx minus 1. So the reason I introduced gaps will be soon discovered while solving this equation. So as you remember that the probability of two outcomes was p plus q plus is equals to 1, right? So here we can manipulate this equation by, not manipulate, let's say we'll tweak this equation with these two variables, not variables, probabilities to be precise. So because p plus q is equals to 1, we can write this like this, right? Now we'll multiply and open that bracket on the left hand side. Right, now as we remember, we have gaps, right? Here, this is our gx. We are trying to define a gap between this position x and the intermediate position x plus 1, this position x, and then one position backwards, which is x minus 1, and we denoted that as gx minus 1. So that's our gap. So we'll try to rewrite this equation to define our gaps here. So let's say there is q, then qx. I'll put qx minus 1 from right hand side to the left hand side. Then I'll pull the left hand pqx to the right hand side, and then we'll factor out. And this gives us our gaps again, right? So now it will be q into gx minus 1, and that will be p into gx. So we can write this in an equation now. Let's say gx is now q by p into gx minus 1. So this can be one of our equations to describe the gaps. We'll name it as fourth equation. So let's put some values in x as we have this fourth equation. So solving fourth equation. So let's take x is equals to 0, then g of 0 is equals to I mean, when we are starting with 0, then it will be 0 because there's nothing to go behind 0, right? Because 0 was our ending point, right, on the number line. But when we go to g1, then it will become again qp into g0, right? Because 1 minus 1 will be 0, right? Now g2 will become q p into g1, but we can write that recursively using qp into qp into g0. So as we can see from here, it will become a geometric series resulting in g of x is equals to q by p raised to the power x into g0. And as we know, it looks like a geometric series. So that will be g0 into 1 minus q, that will be x minus 1 here, because we already have g0, g0. So q by p raised to the power x upon 1 minus q by p. So we can make this equation as our fifth equation. Now we can use gx to put it in the qx equation that we saw here. because Qx comprises of Q0 and the gaps that happened, right? At the X position, in order to come from 0, there are gaps that have happened in order to get to point X. So we'll put equation 5 in Q of X. So as you know, Qx is equals to Q0 plus G0, G1 till Gx, right? And as we already know that Q0 was our probability 1. So we'll put that value here, right? And as we know that Gx, from G0 till Gx, it's a geometric series, what we calculated above. So we'll put the value here, that will be G0 into 1 minus Q by P raised to the power X upon 1 minus Q by P. Now, as we have our Qx equation, now we can move forward with tweaking this equation to find out the value of G0. Like, what's the first gap that happened, right? So we'll try to find the value of G0 from this. So let's take X's value as A, right? So that will make it QA because of X, because we have put the value of A, right? And we know that QA is equals to 0. So the entire equation at the left hand side becomes 0, and here it will be 1, then G0, then into 1 minus Q by P upon 1 minus Q by P. Now if we put the 1 value at the left hand side and then try to take out the value of G0, that will be minus 1 minus Q by P upon 1 minus Q by P raised to the power X, because this is just cross multiplication. You put it there because this will be minus 1, not 0, so it goes there, and that is our G0 value. Now that we know what's in our G0, we can move forward in finding out Qx. So let's see what our Qx looks like. There was a small mistake here. Here it will be Gx minus 1, not Gx, because that was the premise of geometric series, that the equation or the series goes till a r raised to the power n minus 1. That's how it becomes 1 minus r raised to the power n. So let's move on with our equation G0. Now we can use this equation to find the value of Qx, which is the probability that from position X, when are we reaching ruin, that will be X here, and when are we reaching the state of 0. which is getting broke. As we know that qx is equals to q0 plus g0 plus the consecutive values till gx minus 1. Now we will put the value of g0 that we have derived, right? And that will give us, also remembering that q0 was 1, right? So the resultant equation becomes q0 plus minus 1. Okay, there has been a silly mistake. That should be a here as well. So we'll correct that real quick. Yes. So now coming back again, that will give us 1 minus q by p, 1 minus q by p raised to the power a into our geometric series that we found earlier, which was 1 minus q by p raised to the power x upon 1 minus q by p. So we'll put that again here. So that will be 1 minus q by p raised to the power x, and that will be 1 minus q by p. So these terms will get cancelled out. So the resultant equation becomes minus q upon p raised to the power a plus q upon p raised to the power x upon 1 minus q by p raised to the power a. And now when we remove the minus negative term here, so we'll multiply the whole equation with minus in numerator and denominator. So that will give us q by p raised to the power a minus q by p raised to the power x upon q upon p raised to the power a minus 1. So this is the probability that starting from the position x, we can get broke as a gambler from the position x, 0 and a. This is the probability. So now that we know the probability of going broke is this, starting from x. Starting from x. Now this is a general equation. General equation. But what if the coin flip is fair? Because this will cover the unfair and fair probabilities. Now this covers given that the coin flip is unfair, which means the probability of coin flip happening will be uneven. The probability of getting heads and tails are not equal. That's what we mean here. But let's say case P and Q are equal, right? So here we can use our original equation Qx is equals to Q0 G0 till Gx minus 1. Now here we can do one thing, that so Qx becomes Q0 plus x into G0. So why am I writing x here? Because this time the gaps that are happening, they will be equal, right? So our qx becomes this in the case of equal probability. Now we need to find G naught, not G naught, I mean G0, both the same. So we need to find G0 again. So we will use the same trick. We will put x is equals to a, that will give us qa, and then qa is 0, right? So then qa will be 0, that means left hand side becomes 0, that will be q0. Oh, sorry. Oh yeah, it's right. So q0 had the value of 1, right? Here it will be 1 as well. So that gives us the value 1 plus x into g naught. So we get the value g naught, g0, which is 1 by x. So if we put that again into putting so qx becomes 1 plus x into, okay, there's slight mistake here, it should be a, because we have taken the value x is equals to a, so that will be g0 is equals to minus 1 by a. So that gives us the value x into minus 1 by a. So qx becomes 1 minus x by a. So that's our equation in the case of equal flips, where p is equals to q. So let me write down both of the equations. In case p and q not equal, so qx becomes q by p, a minus q by p raised to the power x, then q by p raised to the power a minus 1, and then for the case 2 where p is equals to q, in that case our qx becomes 1 minus x by a. So that's it. These are the two equations for getting the probability that a gambler starting from X position will go broke before reaching A. Before reaching A, this is the probability that the gambler will go broke.